session, and Moses will introduce himself, and then he will start the session on gas and diesel power plants. And in the end, when you have any question, you can ask in the end, please. So over to you, Moses, please.
Okay, good day everyone. My name is Omuyadri Moses. Presently, I'm the plant maintenance manager of Domino's Nigeria. Can you hear me, please?
Yes, yes, please.
Yes, I'm the plant maintenance manager at Domino's Pizza. So I will just give you a simple explanation on gas and diesel power plant. Let me start with gas power plant. Gas power plant, as the name implies, it's a power plant that uses gas as its working fluid. I will come again. A gas power plant is a power plant that uses gas, GAS, as its working fluid. Now, you may ask a question, what kind of gas does this gas power plant use? In the energy mix, we have what they call energy mix, MIC, energy mix, MIX. The energy mix encompasses the natural gas, diesel in the hierarchies. So diesel is the highest, most expensive in the energy mix. So among the natural gas came in three forms. So we have the PNG, the pipe natural gas, PNG, PIPE, pipe natural gas. Then we have the LNG, liquefied natural gas. Can you hear me, please?
Yes, yes, yes. Repetition make us clear, please. Yes, that's nice.
If they have any question, they should just ask me. I will answer them.
Yes, yes. Attendee can ask the question meanwhile if they have any issue, please.
Okay. Now, then the natural gas came in three forms. We have the PNG, the pipe natural gas. Then we have the LNG, the liquefied natural gas. Then we have the CNG, which is the most expensive among the natural gas arrangement, which is the compressed natural gas. So that one come in a skid like a tank. Now, the way the thing is routed, in a power plant, gas power plant, if you are using a pipe natural gas, you will need what we call a PRMS. A PRMS, which means pressure reducing metering station. Pressure reducing metering station. Now, there's a supply of a gas from the supplier or from the vendor that you are buying the gas from. So when the gas is coming through into your gas power plant, the pressure needs to be reduced because from the supplier end, there's a high pressure where the gas is coming from. The pressure can be 15 bar, depending on the distance. It can be 15 bar, it can be 6 bar, it can be 7 bar, it can be 10 bar. Depends on the location of which your gas power plant is located. It can be an island location and it can be a grid location. Just depends. So when this gas with high pressure get to the PRMS, the PRMS function is to reduce the pressure to an allowable pressure that can get into your gas regulator before it enter into your gas mixer, which is a component of your gas generator. I will come again. The PRMS function is to reduce the pressure of the gas that is coming from the supplier. It can the standard pressure of which the PRMS can reduce the pressure is 2.5 bar. from the out from the incomer. The outgoing into the gas will be 2.5. The incomer will be like 15 bar or 10 bar or 7 bar or thereabouts. So when it gets to the PRMS, it drops down to 2.5 bar. The whole essence is for us to use the gas in the gas generator in order to make that plant sustainable. Now, when the gas is being reduced to 2.5 bar, first of all, before I move further to the explanation of how the gas works inside the gas generator, now we have several compartments inside the gas power plant. The first compartment is the gas generator shelter, which is called the generator shelter. Shelter, S-H-E-L-T-E-R. The gas generator shelter, that's where the generator is located. That's where you mount your generator. Then the second compartment is your control room. In your control room, you have different panels, different switch gears. They are being installed inside the control room. Inside the control room, we have different switch gears with different function. Now, the function of the switch gears inside the control room, the name of the switch gear inside the control room, one, we have the AS panel, HAS. It's called HAS, the AS panel. The purpose of the AS panel is to accommodate the auxiliary of the generator. Now, what are the auxiliary of the generator? That means the controls that controls the auxiliary that is attached to the generator inside the generator shelter. That's the function of the purpose of the AS panel inside the control room. Now, we also have what we call the GLF panel. GLF, generator load field. The essence of the GLF panel is for synchronization. It can synchronize one or two generators together in order for all of them to harmonize together, for the load and the supply to be harmonized, in order for the customer to receive an harmonized functional supply, but with a different capacity. Sorry, can you hear me, please?
Yes, Moses, it's clear. Yes.
Are you getting it clearly?
Yes.
Okay. Now the function of this now, that's the AS panel. Then we have the GLF panel. Then we also have the LMS inside the control room. The meaning of the LMS is called load management system. The function of the LMS is for the harmonization of all the sensors that is being installed in the generator. So they are being controlled by the LMS. So in other words, if you put off the LMS, the generator will be off. If you on the LMS, the generator will be on. Now, the interesting part of LMS is that you can install a SCADA system. You can control your generator using your laptop with the aid of a SCADA through the LMS, because you just carry the cable from the LMS and attach it to your laptop and install a SCADA software, and you can control your laptop, both your various outgoing from the various outgoing, the feeder and everything. You will see all the total load from your laptop through the LMS. So the function of the LMS is the brain of the generator. It's the brain. It houses all the sensors, all the control components inside the generator. They are all channeled and routed to the LMS. Another panel that I find inside the control room again is called the MV panel, the medium voltage panel. Now, the purpose of the medium voltage panel is, for example, if you have a customer, because the whole essence of establishing a gas power plant is either you want to use it in a factory or you want to sell the power to a customer. For example, if the factory, for example, is located in the distance from where the gas power plant is being installed, you will need to use what they call the medium voltage panel. And when you're using a medium voltage panel, meaning that you need a step up and a step down transformer. You need a step down transformer from the receiving end, and you need a step up transformer from your own end. Because the essence of this generator, the generator rating is 415 volts. 415 volts is the rating of a gas generator. Of a gas generator is 415. If you are using for industrial purposes, because it's different from when you are using for your normal residential or conventional purposes. For industrial purpose, the setting of a gas power plant is 415 volts. That's the rating. Although there are some gas power plants that come in 11,000 volts. That means you don't need a step up transformer in such rating. So now, the medium voltage panel, the purpose of it is to increase the voltage and to increase the voltage against losses. And the losses that we are trying to prevent here is what we call impedance loss, reactant loss. So those are the losses that you can incur when you are transferring a voltage, when you are running a current from one location to the other. Now you may ask the question, what is different between voltage and current? The difference between voltage and current, because these are several terminology you need to learn, you need to know in a gas or diesel power plant. Because you need to know the basic, which is voltage, current, power factor, reactive power, apparent power, and real power. I come again. There are several terminology you need to know in a gas or diesel power plant. You need to know what the meaning of a power factor is. You need to know what a reactive power is. You need to know what an apparent power is. You need to know what a real power is. You need to know what a frequency is also, a frequency. So all those things are several terminology you need to learn. You need to know the difference between voltage and what? Current. Now, I'll give a simple definition with a simple difference between voltage and current. Because of how broad this power plant lecture is, if we are unable to complete this section today, we will extend it to another section next time so that I can continue, because the thing is very, very broad. But I will try as much as possible to touch some areas that can help and assist you in the future. Now, the voltage, the other word for voltage is called EMF. 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 It's called electromotive force. Electromotive force. The voltage is the force that moves a current in a circuit. Voltage is the force. Voltage is the force that moves a current in a circuit. So if there's no voltage, what do you mean? A current is what? Constant. Current cannot move without voltage. Current goes nowhere without voltage. So in a circuit, when you have a circuit, you need a voltage to transfer your current from one location to the other. If you have any question among this session, you can just pause me and ask your questions. Then I answer your question and proceed, because power plant, either gas, diesel, is a very broad lecture. Now, the whole essence of to increase the voltage in order to move a current to a particular distance is because of losses. Now, resistance are impedance, are motions that hold current from moving. Resistance are motion that resist or hold or hinder the flow of current in a circuit. It hinders the flow of current in a circuit. Resistance. So the process of voltage pushing a current in a circuit, resistance hold voltage from moving, hold current, sorry, from moving. So in the process of dragging movement, there will be losses along the line. So those are the losses that we incur. So if, for example, you are moving 415 from location A to location B, if you don't have control for the losses, you may eventually receive 300 something volts along the line, which should not be enough for the receiving end for usage. So in order to move to get the actual 415 in a particular location, you need to step up your voltage to increase the strength of the voltage to move the current in the circuit. So that's the reason, that's the whole essence why you have an N-beam panel in the control room. So along the line, those are the only panel you can have inside the control room. Now, the other compartment that you can have, now, I've mentioned two compartments now. I've mentioned a gen shelter, I've mentioned a control room, and now I want to mention the office. Now, the main office is a place where you can route your connection to, you can view the operation of your generator in your office. But how can you view the operation of a generator in your office? Some of you may ask, it is so awkward. But it's possible for you to view your operation of your generator in your office through the aid of a SCADA softwares. When you install the SCADA softwares in your laptop and you connect the cable from your LMS, that panel inside the control room called LMS, connect your cable from there to your laptop, you can access all the information in your various generators, either 1, 2, 3, different capacity, from 1 megawatt to 1.5 megawatt to 2 megawatt to 2.5 megawatt, regardless of any of the megawatts. You can view their various operations inside your laptop with the aid of a SCADA system. SCADA is a software, SCADA. It's for you to supervise your operation. That's the whole essence of a SCADA. So instead of you entering now, before I move further, the effect of you, the operator, staying in the control room, or why it's dangerous for an operator not to stay inside the control room is this. When you are using a low voltage GLF panel, for example, the low voltage GLF panel has so much radiation that can affect the operator. It can affect your nervous system. It can affect your peripheral system, your peripheral nervous system, or your central nervous system. It can affect your function. It can release positive ion that can affect the function of your neurons in your body. That's why it's not advisable for an operator to sit inside a control room. So it's advisable for an operator to be in the office to monitor the operation. Once in a while, you can walk into your control room and check your HMI, which is embedded inside the AS panel of the individual AS panel of each generator. HMI means human-machine interface. The human-machine interface is what you use to assess and seize all the internal operations of your components in the generator. For example, the various combustion chambers, their temperatures, you can assess it through your HMI. You can know the temperature of what bank A is having and what bank B is having. And you know for sure that every power gas generator that ranges from 1 megawatt and above, they are all V engine. They are V engine. It can be 16 cylinders, it can be 12 cylinders, it can be 20 cylinders. Depends on the kind of configuration you are looking for. Now, in a 12-cylinder generator, the bank A has 6. The bank B has 6. Now, the bank A now, the temperature you can be seeing there, it ranges from 300 to 450. Now, anything below 300 you have to check your spark plug or your ignition coil cable. That's the whole essence why you need to monitor your HMI. That's the whole essence why you need to be checking your SCADA system consistently. So these are the things, the modalities you put in place when setting up a gas power plant. And this kind of modality can also be incorporated into the diesel power plant. Because the same setting, the only difference there is that you'll be having diesel generator inside the gen shelter instead of gas generator. That's just the difference. The old panels, everything, they are all the same. You can have auxiliaries in your gas generator. You can have auxiliaries also in your diesel generator. But the major difference between these two formats is that first, diesel generator is more rugged than gas generator, I would say, from experience, because whenever we have anything like impact load, for example, when I was working with Cowbell, we are running a gas and diesel power plant, and the gas we are using there was a PNG, pipe natural gas. When load come into the generator, like impact load, for example, a load of like 500 kilowatts just fall on the generator. Generator, you will see it just be vibrating, be shaking. We just want to, sometimes we receive downtime as a result of impact load from different factories. So diesel generator can withstand impact load more than gas generator. Another difference between gas and diesel generator is that gas generator, the parts are very expensive. The parts are very expensive. A gas generator uses several modified components that are readily expensive whenever there's a damage in it. And all the operations embedded in a gas generator are readily expensive. The only reason why people run away from diesel generator because the working fluid, which is diesel, are very expensive. That's why people usually prefer to use gas. But at the same time, if you're using a gas generator, you need an experienced person to handle that plant. If not, you will incur a lot of loss. Because if the person does not understand the operation, does not know some terminology which is attached to a gas power plant, you will only be having downtime and damage in several components inside the gas generator. So gas generator is for experts, it's for intelligent, for experienced personnel. It's not meant for someone that's learning, because if you put someone that's a learner there, it will cause a lot of damage for you and you will incur a lot of loss. So it's for an expert, for someone that has a great deal of experience on a gas power plant. Now going further. Now inside the gen shelter, if you are using a manual operation, because we have two kinds of operation in a gas or diesel power plant. Now we have the manual operation and we have the automatic operation. We have the manual operation or we have the automatic operation. Now, manual operation is very, very difficult in the sense that it's stressful. Let me just use the word stress. It will incur a lot of stress on the operator because every of the operation equipment are in different location. Instead of you to use your laptop to on your generator, use your laptop to close the various breaker from the outgoing. You'll be going differently to the different compartments to be closing the breakers individually. You go to the different factories and be closing the breaker individually. So it will incur a lot of stress on the operator. So that's why it's advisable to use an automatic operation when establishing either a gas or diesel power plant to make it easier for the operator to run and also for the customers to run, to have a zero downtime. And also, it will also aid you to know what is faulty inside your generator. For example, if your generator is having a problem with the oil or the oil level is going down, from your HMI, your human machine interface that is embedded in your AS panel in the control room, you can see an alarm that will pop up through the HMI that your oil level is low. You have to top your oil. So from there, you go to your oil tank and put on your oil pump. You see oil will flow into the generator. That's the importance of using an automatic system in operation. But when you're using a manual operation, if your oil level is low, you will not know. You just be doing a try by error. You'll be guessing.
Audience, do you have any question? Otherwise, please mute your mic, please. Thank you. Yes.
Do you have any question, please?
Azim, please manage them, and if any have an issue, just convey them on WhatsApp so that they have muted
Okay,
your
sir,
mics.
sir,
Yes,
kindly
yes.
please make me presenter so that I may mute them by myself.
Okay, okay. Moses, please continue, please.
Okay, do you know what will happen? Can you hear me, please? Abib.
Yes, Moses, I can hear. Yes, please continue because there is someone whose mic is on, so we are requesting him to just
He has to mute.
mute. Yeah.
It's creating an interference for me. I'm hearing some voice in the background.
Yes, Moses, please continue, please.
Okay. Now, the gas power plant, like I said, I've explained to you the various compartments. Now, in the gen shelter, like I said, if you are using the kind of, it's preferable to use automatic operation because it make your work easier, to make you to identify faults seamlessly without consulting, doing any try by error, because most of these gas generators operators or diesel generator operator, what they are doing is try by error. And when you are doing try by error, when troubleshooting, it will cost a lot of things. First, it will affect your return on investment for the investors that establish that plant. Because in every plant, we have directors that invest their money to establish that plant, either for industrial purposes or for commercial purposes. You can be selling power, or you can have a power plant in your own factory. So if you are doing trial by error, you are just doing a guesswork to look for fault, you will waste time consuming, you affect production, you will affect target, you will affect return on investment, you will cause the company losses. So it's expedient you incorporate automatic control system in your power plant, either your gas or diesel, to enable you to run your plant efficiently at zero downtime. And whenever there's a fault, you can easily trace and solve it immediately and pick up and start your power plant immediately. Now, in a gas power plant, it has its own advantage and it has its own disadvantage. Of course, I have told you several disadvantages of a gas power plant. That first, the parts are very expensive for a gas power plant, are very, very expensive. Something like different components there, they are so expensive because the gas power plant that I've used MWM, I've used Caterpillar, I've used MTU. Those parts are really expensive. So it's advisable that if you are incorporating yourself into the gas power plant establishment, you will need a backup. And several industrialists make this mistake. You need a backup, you're going to be using diesel generator as your backup. Yes, diesel generator is good for a backup, but you will still be incurring cost. The whole essence of establishing a gas power plant is to use a very affordable working fluid for your generator to run, which is the gas. Now, in the various form which the gas came from, which is I told you before, I've explained before that the gas came in three forms. We have the PNG, we have the LNG, and we have the CNG. I come again, PNG, LNG, and CNG. Now, PNG is the most used in every industry because why? It's the cheapest and it's a dry gas. It doesn't require you doing any other operation before using the gas. You don't need to go and start installing a boiler or installing several components to achieve a dry gas. That's why major industrialists use a pipe natural gas. The gas has already been processed from the factory or from the supplier before it is sent to you. So the only thing that the supplier will install on your own compound or where the gas is coming into is just a PRMS, which is the pressure reducing ammetry station to reduce the pressure of the gas that's coming from the supplier. That's all. You don't need any stress in using PNG. But when you are using LNG and CNG, it requires a lot of stress. Because why? The CNG comes in a container called a skid. 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 Now, this skid has a very high pressure. The pressure of the skid is very high, and the temperature is very low. So what you do is that you need to pass the skid through a boiler. The gas inside the skid, which is the compressed natural gas, through a boiler. And you need to install like 2 PRMS inside your station, your substation. First, the first PRMS that we have, that we view the real pressure of the gas that's coming out from the skid. Then when it passes through the boiler to reduce the pressure and the temperature, reduce the pressure so that the gas will not be freezing. Then you now pass it through another PRMS to be able to reduce that dry gas that you have achieved. So imagine all the components, all the modalities you need to put in place when using the CNG. That's why people prefer to use PNG, most likely, because it's easy to use, it's a dry gas. What you just need to do, just pass it through. But the disadvantage of using PNG is that most times the supplier wants to maintain the pipeline, so they will cut off the gas. I know what that means. When the gas is being cut off, you will have low pressure on your PRMS. And the allowable pressure that is sustainable for the generator is 2.5 bar. But when the pressure is below 2.5 bar, your generator will just shut down. So that's the disadvantage. And when your generator shut down, you will not have any gas power plant to run. So now that's why people use backup. They use diesel generator for backup. Immediately there's no gas, they will run to their gas power plant, their diesel power plant, and change over to gas power plant and isolate the gas and run diesel until this gas supplier now finish their operation and their maintenance on their pipeline. They will now supply gas back. And that time, it may take 1 week, it may take 2 weeks. There was even a time when I was working in one power plant like that, like 2019. I was working in one power plant as an operation and maintenance engineer. We had a downtime we had a gas outage for like 2 months. We had gas outage for 2 months. And that was a serious issue for us because we don't have a backup. The only backup we have was not enough. The only backup we have was not enough. We just have like 500 kVA diesel generator, like 2. Then we have 650 kVA generator 1. Just small backup. And that backup is not sustainable for our customers. So we have to shut down the full plant and just be running only black start. So I'm recommending for every industrialist to have a CNG as a backup. Why should you have a CNG as a backup? CNG is 50% lesser than the cost of diesel. First, to save you cost. Then secondly, CNG is mobile. You can take CNG anywhere. You can take it from Pakistan to Iran, from Iran to Saudi Arabia, from Saudi Arabia to Dubai. You can move CNG to any location, which is key. It's just like this, your normal cooking gas that you have cylinder at home, 12.5 kg, used for cooking. That's the way you can convert it to anywhere, because this kit it comes in like 9 bottles. And those 9 bottles, they can sustain you for like 4 months if your load is not much, because the more your load, the more your generator runs, the more your gas is being consumed. So that's it. So sometimes when you're doing maintenance, you save gas on your power plant. So that's just the brevity about gas power plant. So now, before I go into the control aspect of gas power plant, do anybody have a question to want to ask me about the gas power plant? Because I want to enter into the control aspect.
Yes, anyone having a question on gas power plant, please ask. Um, Moses, my question was that you told me that the manual operation, there is a economical impact on operators or stress on operators. I could not understand what do you mean that.
Is that all?
Yes, and then another question, you gas versus diesel power plants. You discussed about parts. There is a damage or loss regarding parts of the gas power plants, but I could not understand what does that mean also.
Okay, I will explain manual operation. I said manual operation is stressful because the operation is you use your laptop. There's nothing like SCADA system in the manual operation. There's nothing like SCADA system. There's nothing like TEM or HMI in the manual operation. In the sense that if you want to on your generator, you will go into the gen shelter yourself. You go and put on the generator from the generator. Then you come to the control room. You will close the breaker from the control room. Then you run to the customer end and go and close the breaker for the customer end. So you'll be running from SCADA to go and be closing all this breaker. Because the essence of putting control is to ensure that the breaker, you can close the breaker with just pressing a button from your laptop or from your LMS. You can press close from your LMS. All the breaker will close. Either from the customer end or from your own substation, the breaker will close. But if you're using manual operation, you'll be running to the different locations. Normally, if you want to start the power plant, you will have to go to your laptop from the office. You know, I think that we have the 3 compartments inside a gas or a power plant. We have 3 compartments. We have a gen shelter, we have a control room, and we have the office. Now, this cabling, the cable is being routed to the office so that to enable you and to ease your stress, so that instead of you coming into the gen shelter to on your generator, you just need to go to your laptop and go to the generator you have to on and click on. It will just your generator will start from your office without you going to on it from inside the gen shelter. But with a manual operation, those things are not put in place. You will have to go inside the gen shelter, press on. You come to your GLF. When your generator has run, you will hear a sound. Boom. It will come to your GLF panel that the load has entered to your GLF panel. So what you just do, you press the breaker. Manual operation is very dangerous too. What about the situation where the generator is rated in 415 volts? What about the situation where the voltage, there's a leakage in the voltage? You went down and press the breaker and there's a spark. It has happened to one of my colleagues. When you're running a manual operation, immediately you run there and press the breaker, there was a spark and it splashed on his face. The arc happened so accidentally and he was rushed to the hospital. So manual operation is stressful and it's risky because it put the operators in danger. You go to different locations to be closing the breaker. Imagine if, because in a step, when you are sending voltage, sending your current to a longer or a far distance, for example, if your customer, for example, you are living in Dubai, you want to send voltage to Abu Dhabi, for example, and your customer is in Abu Dhabi and you are living in Dubai. So, and your power plant is being established in Dubai. So what you just do, you run your cable to Abu Dhabi so that your customers will have the control, will have light through your control. That's easy. That is easy. I'm just giving you an example of manual and automatic operation, for example. Now, for a manual operation now, at your customer end now, since the distance is much between Abu Dhabi and Dubai, you will need a step-down transformer at Abu Dhabi. Then you will need a step-up transformer at Dubai. Because a step-up transformer will increase the voltage from 415 volts to 11,000 volts. And we also have a step-up transformer that can even increase to 33,000 volts, depending on the distance. So let me just use medium voltage, for example, medium voltage of like 11,000 volts. Increase to 11,000 volts and send the voltage straight to Abu Dhabi. Now, in Abu Dhabi, we have a step-down transformer, and we also have an MV panel too that will receive the 11,000 volts, because from the panel, the voltage will go to the step-down transformer and will now enter into a low voltage panel, which is 415 volt panel. Because in your own substation, you will have an MV panel, you will have a step-up transformer, and of course, you know, if you have a transformer, a step-up transformer, you will have an RMU. Because I will come to that. I will come to that aspect. Now, this is manual operation. If you close the breaker, you go to your MV panel from Dubai, you press the breaker. You will need to take your car and drive down to Abu Dhabi and go and close the breaker at the MV panel so that the voltage can enter to the step-down transformer. So the voltage can be reduced from 11,000 volts to 415 before you now enter the panel. So imagine the stress you will pass through from Dubai to Abu Dhabi to go and close the breaker. Just to close the breaker, you are going to Abu Dhabi. Why not from your system here? You have the network on your system. As you close the breaker from here, to make boom. Once your customer receives it, you will see it from here. Then you close it again. Then we have their supply there. Easy, no stress. That is what automatic control does. It makes your work easier and stressless. So if you want to go to your customer end at Abu Dhabi, what you just need to do is you just want to go and do a check or a routine inspection. I will come to maintenance aspects. That's why I said this class will be sectioned. We'll be able to do this class like 3 or 4 times because it's a very, very broad topic. Very, very broad. You can see how I'm saying it without even looking at a book. I'm talking from experience. And you can quote me anywhere. Anything I'm telling you is standard. So why not ease your stress and incorporate an automatic control system where you can just close your breaker from here? Then everything is gone. The customer just call you. All you have to do is just to carry your walkie-talkie or you carry your phone. You call, hello, Mr. Michelle Power. Yes, please. Do you have light? Yes, you have light. Okay, thank you very much. It's your stress. Why would you now just, for manual operation, you close breaker from here, manual, you close the MV panel from here, you enter your car, because you'll be filled with pressure. You'll be stressed, because first, your employer will be on your neck. Hello, Moses, where are you? Customer is complaining that they don't have light. I don't want to start production. Where are you? Sir, I'm going to Abu Dhabi now. Please, just give me some time. I'm going to Abu Dhabi. You enter your car. What about if you have accident on the way? What about if you have high blood pressure on the way? So that's the stress involved in having a manual operation. Now, I'll give you some practical example. When I was working with a production company called Cowbell, they're into dairy production. They were using manual operation when I joined them in the company. So in that place, we have 2 types of GLF panel installed in a control room. You can either install a low voltage GLF panel or a medium voltage GLF panel. Now, then we are using low voltage GLF panel, sorry. So when I start up the generator, I was the only one on duty because the technician that was assigned to me was kind of engaged, was sent to another state to go and do a job there because they don't have technician there. So I was the only one on duty operating all these plants. We are having like 7.5 kVA gas generator. One 7,500 kVA. One is 2005. We have 3 of it, 3 2005, 2,500 kVA generator. That means 2 megawatt generator. each. I mean, we have 6 megawatt and 7,500 kVA generator like that. So after I start generator, I run to the synchronization panel, because the GLA panel is also called the synchronization panel. I run up, I press the breaker from the synchronization panel because we have two different kind of synchronization panel. We have a synchronization panel that can have both the incomer and the outgoing separate. And we have the one that can have both incomer and outgoing in the same box. So if they are in the same box, it will be easier for you. When you close the breaker, you close the breaker for the different outgoing manually. Then when you finish, you go to the different outgoing, the different customers, and be running a tasketer. When I was running to close the one at dry powder, I fell down. My hand peeled. My hand peeled off. I was injured seriously and I was taken to the clinic. So manual operation is very stressful. It gives you a lot of stress, a lot of tension, and a lot of pressure. Imagine, for example, a customer will have a challenge in their end. Instead of you to see the problem from your own laptop, from your own LMS, beeping that ping, 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 a customer is having challenge in that place. The customer will be the one to notice the problem and not call you that, hey, Mr. Ahmad, we don't have light in our place for 2 hours now, and it's affecting production. You are not aware of it. Because why? You don't have any control in place. So I don't know if that have answered your question for the
Yes,
manual
Moses,
operation.
yes, thank you for the detailed answer. I understand that. And next,
Okay.
Uzair and then Umar Hanif and Azim also want to ask question to you.
Let me answer the second question from this second guy, which is from the same person that talked about why is damages occur in a gas. Now, if you employ inexperienced operators, you will incur damages on your gas generator because why? The person does not know, because in the gas and diesel generator there are two different things. A gas generator cannot run. It has what they call actual power. Actual power has a control load in the sense that if the load goes below 30%, generator will shut down. That's how a gas generator is configured. If it goes below 30%, generator will shut down. If it go above a particular percent, like 70 or 85%, it will shut down. So if you don't have somebody that have those understanding, you'll be having downtime every time. And when there's so much downtime and the person does not know the modality involved in load control, you will have damages in your part. It's inevitable. You cannot control it. You will have damage. And when a part damage in a gas generator, you will incur serious loss because a gas generator part are very, very expensive. So that's the essence of why you have damage, because you employ inexperienced operators to run the plant. So in a gas power plant, even if you want to bring someone that doesn't have experience, or you must have an experienced person on ground to monitor that plant. So I don't know if that have answered your question for the damage aspect.
Yes, okay, thank you for that. And let's spare time to other audience. I have two questions, but I will later on ask you. Let's Uzair, please ask question, and then Umar Hanif and Azim and Sadat Alvi, please.
Sir, my question is that I have witnessed myself a gas power plant named as a Turbomac, and that was like generating almost 22 megawatt of generation. But at first, when it was installed, it has very low efficiency because the exhaust gases were not directly used. But later, there was a change in which they were using the exhaust gases of the gas power plant and making steam in the second cycle. Like, how does that process work? Like, they are trying to increase the efficiency of a gas power plant by using that exhaust gases from the gas power plant and generating steam again to generate more electricity. Is that like applicable in real life?
Who's the person that asked that question? Please. What's your name?
Yes, Uzair asked you question. This was Uzair.
Okay, there. See, actually, you can use exhaust gas to increase the efficiency. That's why you need to incorporate there's a component in the gas generator called the turbocharger. The turbocharger, we have the exhaust turbocharger. It does that. It uses the exhaust gas back to increase the efficiency of the gas entering into the gas mixer. Because sometimes, when the gas comes from the PRMS, it's dropped to 2.5 bar. So from the PRMS now, there's a pressure regulator that also, there was called primary and secondary pressure regulator before it gets to the gas line, before it enters to the gas mixer. And there's a component that opens and closes, depends on load that's eating the generator. Now, for example, if the gas that's coming into the fresh gas that is coming into the generator through the gas line from the PRMS, then when it gets to the gas mixer, because the stepper motor will be the one to open the step through, maybe if the load that is coming in is not much, like you said, low efficiency, for example, under efficient, that means when something is underused, it's coming in is not much. The exhaust turbocharger will use the exhaust gas to pop in, forcing much air into it, because sometimes this filter, they are blocked because the way the gas generator works, it uses air and uses a gas mixed together before it goes to the compulsory chambers. So when the air is not enough, there's an extra air forced in from the exhaust through the exhaust turbocharger to increase the efficiency of the performance in order for you to achieve the right temperature on the various combustion chambers. That is the essence why you need to have a temp evo, which is the HMI, to see these temperatures. If temperatures go below 300, know that there's not enough air that's coming in to the gas mixer. So automatically, turbocharger is incorporated there to assist that air through the exhaust air that's going out. Have that answered your question?
Yes, sir. That's answer to my question. Thank you so much, sir.
You're welcome anytime.
Yeah, Umar Hani, please. Azim,
Okay, sir. I've been meaning to ask, which gas is the most efficient gas for the gas power plants? But which gas
Okay.
produces the most energy?
Any question? Any other question? Anif,
Umar
do
only
you have any other
have this
question?
one question, and another person have also question, but later on, inshallah.
Okay, let me answer Anif. Anif, like I said, we have just one gas for the operations, and this gas comes in three forms. We have the PNG, LNG, and CNG. Now, in terms of efficiency comes with reliability and availability. When you talk about availability and reliability, you go with CNG because it's something you can monitor. You can monitor the volume of gas inside the skid. When the volume of gas is going down, you quickly request for another gas before that one finish. So you don't wait for that one to get exhaust before you bring in more gas. So you monitor the volume of gas. When the gas is reducing from inside the skid, you quickly call your supplier to bring you more gas. CNG is perfect because PNG, which is the pipe natural gas, there is no control for it. Sometimes, maybe when you have a larger production to produce in your factory, or for example, your customer, that particular day is the peak period for them to produce a larger quantity of their product, and they need more light to produce this goods. Supplier of gas from PNG will just call you. Hello, Mr. Anif. sorry to bother you. We want to tell you that we want to do maintenance on our pipeline. Please, we'll be cutting off your gas. And you did plan for that. Shortly after, you just see your pressure of the gas will just reduce from 15 bar to 0 bar. Your generator will just off automatically. Boom. So there's no control for the PNG. So CNG is perfect for you to control. Does that answer your question, Anif?
Azim, please ask next question, please.
Okay. Hello there. So I have a question that if we look at the chart, the steam power stations are like just 25% efficient, while diesel power plants are like 25% efficient. But hydro power plants have much higher efficiency, like 85%. Then, sir, why are we in this modern world? Why are we talking about these power plants? And we are working on these power plants instead of going towards hydro or other renewable sources.
Okay, the subject of this course, of this webinar, is gas and diesel power plant. If you Abib wanted me to diversify to more and explain more, because we have different kind of energy. We have renewable. Renewable is cool. Under renewable, we have two types. Let me just give you a brevity of renewable gas before I come to hydroelectric. Renewable have two types. We have the solar PV and we have the CSP. Now, the solar PV is called the photovoltaic. So it uses the photo, which is the light ray, for power generation. So it uses the light ray, then it passes it through. There's a battery that stores the power. There's an inverter installed in place. So the solar PV is on one side, which is using the solar cells, use a solar panel for power generation, in the sense that you just install the panel on the rooftop, then the light comes, then you get your power. Then the CSP uses turbine. It calls concentrated solar power. It's very expensive because of the corporation, the way the things put in place. That's why people don't even go with CSP. After this class, you can go and make research on CSP. It's very expensive, and the highest CSP they've installed so far is like 800 something megawatts so far. And it's not in Nigeria. It's not in even the Arab countries. It's something in the US, in the USA. So it's not practicable because of the cost of materials to put in place. That's why most people usually elaborate more on renewable solar PV. So the solar PV has a drawback, a disadvantage. In a situation where we have a higher capacity load in a substation, for example, or in a company, you will need a larger hectares to install your panels to be able to achieve a reasonable amount of load. What about if there's no solar power? What about there's no sun? What about there's no light solar rays that will come up? What about if we have everywhere is just there's an eclipse, for example, or there's something lunar eclipse or stuff like that? So these are the challenges. But I will explain more on solar on the next class. So the subject of this class is just power plant, the diesel and gas power plant. I don't know if I've explained a little bit about solar PV, so solar renewable energy for you. Now for the hydroelectric is going out is becoming obsolete because there are new technology that have been adopted now for power generation, because you need a dam in order to use hydroelectric. You need a dam, you need a turbine for you to incorporate hydroelectric. Yes, you can have a multiple power source in a country, but not as a company. As a company, you don't. Where are you going to have your dam? So you need something that that can accommodate a particular. It depends on space. If you have the workforce to incorporate space, You can go into multiple power system using solar PV. In fact, where I work, Cowbell, they are using solar PV, they are using solar PV, they are using gas, they are using diesel. They're using solar PV, they're using gas, they're using. So the reason the modality put in place for the solar PV in the sense that they will cable the solar to our sink panel, they will synchronize it with our gas. Have you heard of that kind of technology before? They will synchronize it with the gas to harmonize the voltage coming out for both ends, not to supply it to the outgoing. So in our next class, I will elaborate more on solar PV and how you can even use it with your gas generator to run a power plant. So that's it for that.
Yes, Sadat Alvi, please ask the question.
Sir, so my question is like, since hydraulic power plants can be used as an interconnect with, can be used interconnected with some other power plants like steam power plant or like some other, so can gas power plants can also be uh, interconnected with some other power plants?
Yes, of course. You can interconnect gas power plant with diesel power plant. You can interconnect gas power plants with diesel power plants with solar PV. But what you will need, you will need the what called SFCs. SFCs 20K. It's a new modern GLA panel that was designed by Schneider Electric. It's a very robust panel which have multiples incomer and multiple outgoing. So when you have multiple incomer, you can incorporate several power plants and cable them to the different incomer so that they will now pass, they will now, you will now sync them in that panel when you synchronize them before you now release them to the outgoing. So you can incorporate gas power plants to diesel, you can incorporate it with solar, you can even put in, just what you just need is just a GLA panel. When you have a GLA panel, you can link any power plant together in a GLA panel. You don't even need more stress. It just depends on your money. If you have money, you can incorporate it. Just buy the panel, cable them together, then run them. If you are running diesel, run diesel. If you are running gas, run gas. Cable them to the same sync panel, synchronization panel. They will all sync together so long as they have the same rating, 415, 415, 415. You achieve the same result.
Yes,
Sir, is it peak load power plant or base load power plant? The
Sir?
interconnected one. Is it peak load power plant or base load power plant? When we interconnect the gas load power plant with some other power plant, so what do we categorize it? How do we categorize it?
Okay. You don't have a name for it. Like I said, GLA panel has two types. Either the genetics unit that you are using can either be just the rating that counts. It can either be a 415 or a medium voltage power plant. You understand? Can either be a 415 volt generator or 11,000 volt generator. You understand? So you can sync all of them together in the same plant. It doesn't, you can, of course, there'll be a name that will be generated to synchronize different power plants together. We'll come to that. So let me not just digress because there's so much things on my head I want to release to you guys. If you guys just give me the time to release it. So I'm listening to further questions.
yes, Nuroline, please ask question if you have.
Sir, why we can't use petrol in diesel engine and diesel in petrol engine? What will happen if we do this?
I didn't get that.
Please ask again, please.
Sir, what will why we can't use petrol in diesel engine and diesel in petrol engine? What will happen if we do this?
Why will a gas plant? Abi, can you ask me the question? What she's saying?
I think so. Your question is why in diesel power plants, if we will use the petrol as fuel, what will happen? Do you mean that?
Yes, sir. Yes, sir.
Okay.
Okay, that's interesting. Hello. Actually, petrol is different from diesel because of although they all came from the same fractional distillation of crude oil, but they all have their own what would I call it now? The content inside the unit, inside the working fluid itself. You cannot use PMS. The one you call petrol is called PMS, premium motor spirits. You cannot use it for a diesel generator in the sense that a diesel generator uses an injector, and the injector they also have injector pump incorporated inside the diesel generator. But a petrol engine uses a carburetor. You understand? So a carburetor, the way inside the carburetor there's a skid inside. So when the petrol is much inside the carburetor, that thing will rise, the float will rise to close the flow of fuel from the fuel tank into the carburetor. So the way the fuel is released into the
Yes, Moses, your voice is interrupted. We cannot hear you.
Hello, can you hear me?
Yes, no, I can hear you. Before we are unable to listen you. Yes,
Can
you
you
were
see?
talking about carburetor. Yeah,
Can you see me now?
yeah. No is okay. Yes.
Okay, now sorry, I just have a little outage. Like I said, you can see the challenge I'm facing here. We just have in this place where I'm working now. Before I answer a question about petrol and why can't you use petrol on a gas, you can see there's light now. So these are the things I'm just telling you now. We just have a gas outage. We just had a gas outage. So now our backup here now is diesel. We are using now as a backup. So now we just change over to diesel generator. So these are the effects. When you have a gas outage, there's no communication. I'm the plant maintenance manager here. I would not inform that, hello, Mr. Moses, there will not be gas for a while. We are taking away gas. You can see there's gas outage. So that's why it's not too efficient or it's not too good for an operator to rely or a company to rely more on diesel, on PNG, on pipe natural gas, sorry, because they can fail you anytime. So now coming back to your question, like I said, the PRMS unit uses carburetor, while a diesel generator uses an ejector. So you can't put a fuel inside. Can you hear me?
Yes, Moses, we can hear. Yes.
Okay. You can use the fuel inside a unit like that. So just carburetor and injector, and fuel generator is not efficient, because, for example, you are using something like air condition, your normal, not inverter air conditioner and low voltage AC, for example, in your house. Can you hear me? Can you
Yes,
hear me, please?
I can. Yes, it's clear. Yes.
Okay. You are using an AC, for example, in your house, a normal AC that is ranging from normal voltage rating, 240 volts, 230 volts, 220 volts, for example, and you are using your petrol engine in your house, have you noticed when your compressor want to peak on your AC, you hear a sound in the generator, boom, because the load is affecting generator. So contrary-wise, in an industrial setting, it's not advisable you use a petrol engine because they are not reliable, they are not efficient, they are not efficient in operations. So they are mostly used in residential because in this setting of operation, we have three kind of setting. We have the residential, we have the commercial, and we have the industrial. So you cannot bring a PMS in the industrial setting. It's not even viable. You cannot even bring a PMS to a commercial setting. So you only restrain in PMS to a residential setting. So I don't know if that answers your question.
Yes, sir. Sir, I have another question. What is the purpose of governor in diesel engine?
Sorry?
What is the purpose of governor in diesel engine?
It is to control the intake of diesel into the combustion chambers. Because there's something called speed governors. We have speed governor. We have the governor also that also regulates the speed governor. So also the governor also controls the inflow of diesel into the engine. Is that okay?
Sir, thank you. Yes, sir.
Okay. Yeah.
Excuse me,
Excuse me, sir.
sir. Why do
Anybody have a question?
sir? Why do we use superchargers in diesel power plant?
Moses, your mic is mute. Your mic is mute. Please unmute.
Maybe an issue with my network.
Yeah. No is okay. No is okay.
Hold on.
Yes. No is okay.
Network.
No, we can
Can you
hear.
hear me now?
Yes. Yeah. No is okay.
Sir, why do we use superchargers in diesel power plant engine?
Okay. We use supercharger. We use supercharger in diesel engine in order to increase the efficiency of the operation, in the sense that the whole essence of this supercharger in a generator is because of this exhaust, the large amount of exhaust that is going out from the diesel generator, because it's causing the global impact for climatic change. This climatic change effect, enough of exhaust going to the atmosphere, causing global warming. So the essence of why the manufacturer incorporated that unit in there is for us to be able to increase the efficiency of the generator with aid of a supercharger too. Hello?
Yes. Tahir Malik, please ask the question.
Sir, in a
Yes, sir,
hybrid
got it.
generation system, if you've got different power plants, depending upon the characteristics of power plants, which of them is the most favorable one?
Which one is that? What do you say? Come again?
If you've got a hybrid generation system and you've got different power plants associated in the generation system, which one should be the most favorable one depending upon the characteristics?
In an hybrid, are you saying hybrid power plant?
Yes, sir.
Then which one is the most what?
Most useful one or most favorable one for
The
generation?
favorable one is the diesel. Actually, for now, the most favorable that people use mostly is diesel. It's mostly used because of the availability of diesel and the efficiency of the generator. But aside that, when it comes to cost, we people prefer to use gas, but the most used hybrid sector is diesel.
Yes, Osama.
Am I
Next
okay with
question.
you?
Okay, sir. Thank you.
Sir, why
Assalamualaikum, sir.
Yes, yes. Osama, please ask.
Sir, why we use the lubrication in diesel power plant? Why we use
Why do we use
lubrication in diesel power plant?
why we use lubrication
In
in a
diesel
diesel
power
power
plant.
plant? I mean, in a
Yes,
diesel
sir.
or a gas power plant?
Yes, sir. Sir, why you use
Okay, diesel.
lubrication diesel power plant?
Okay, if I will get you correctly, you're asking why we using lubrication on a diesel power plant.
Yes, sir. Yes.
Okay, lubrication is something you will need to lubricate your various components. The engine. You need to lubricate the engine during operation. You understand? You need to lubricate the engine during operation because, you know, in the combustor chamber, oil is needed in the combustor chamber. Can you hear me?
Osama? Yes, yes, we can
Yes,
hear
sir.
you.
Yes, sir.
Okay, oil is needed to lubricate. You need to lubricate your part. If not, you will knock your engine. That's the essence of lubrication. You create knocking. You will knock your engine. Your engine will knock, and you will incur more loss on that. So lubrication is very, very important.
Okay, sir.
You must gauge your oil. You must gauge your oil or your generator. You must ensure that there's a dipstick in every diesel generator. If you put a dipstick, you break it out, make sure that it's gauged. If it's not gauged, ensure you gauge it before you run the generator. If not, you will knock your engine.
Thank you, sir.
And it also result of wear and tear. It's very, very important. It's very, very imperative you lubricate your engine during operation.
What is difference between open cycle gas turbine and closed cycle gas turbine?
Open cycle.
He mean open cycle and closed cycle gas turbines.
Open cycle and
It's still muted. Please unmute. We cannot hear you. Those people who are asking question, be attentive so that you can, when Moses need to repeat the question, you please repeat it without wasting the time, please, and ask the questions most relevant, please.
Can you hear me now?
Yes,
Please,
yes,
you know
no
what
is okay.
do you know what we do? Ask all your questions so that you can just be fast. Ask all your questions and we're asking them one after the other.
Yeah,
Just
yeah,
ask me.
yes, yes, that will be fine. Mirza Umair, ask your question. Faizan and Muhammad Farooq, Sarakash, ask your question.
Ask all your
Nurulain and
questions.
Adnan Ali.
Ask your questions.
One by one, ask all
Because
the questions. Moses will respond at once, okay, in the end. Yeah. Please ask.
Sir, my question is that is there any diesel engine power plant that is using six-stroke diesel engine?
Yes. Do you mean that I will repeat that? Do you mean that any diesel engine which is using 6 strokes?
Yes, sir. Six-stroke diesel engine improve the efficiency up to 15 to 20%. Is there any power plant that is using six-stroke diesel engine?
Okay, 6-stroke diesel engine. Okay. Next question. Those who have asked question, just deactivate your raise question. Okay, raise on hand, please.
next question.
Muhammad Farooq, your voice is not clear. Please ask again. Farooq?
Can you hear me?
Yes, yes.
My question is, as the world has environmental factors because of this fossil fuel energy, why is the world not moving fast towards renewable forms of energy? Why are we still stuck in the fossil fuel industry?
Okay, next question.
Okay, next question, please. Next question.
Sahar Akash. Yeah, Nurulain.
Question,
Yes,
please.
sir. My question is,
Okay,
can you hear me?
Yes, yes.
I can hear you.
Sir, my question is that what are the methods to improve the thermal efficiency of the gas plant?
Okay, Nurulain and Adnan Ali, do you have still question? Muizur Rahman, do you have any question?
What is the difference between open cycle gas turbine and closed cycle gas turbine? Main difference.
Okay.
Okay.
Muizur Rahman. Any other person who want to ask question, just ask right now so that Moses can answer all the questions. Okay, I think so. There is no other one.
Sir,
Yes.
sir, can you please tell me what are the equipments of ash collection?
Repeat again, please.
Sir, what are the equipments we use for ash collection in diesel power plant?
What are the
What?
equipments which we use for ash handling? Do you mean that?
Ash collection. Yes, sir.
Ash collection, okay, in diesel power plants. What are the equipment used? Okay. Any other? No? Okay, so Moses will answer, I think so. Please.
Okay. Sorry, my operators, they are sending me a message that they have a little challenge. So I'm trying to respond to them on how to solve the problem. Why I'm answering your questions gradually. So, okay, the first question is, sorry.
And also,
The difference
Moses,
between,
two more questions. One is cost of
that-
energy. If you can also write the question that cost of energy for comparison of cost of energy for gas and diesel power plants, and also if other power plants comparison with other power plants in terms of cost of energy per unit cost of energy kilowatt hours. And the next one is synchronization panel is GLI panel. GLI panel, you mean GLI. What does it mean, GL abbreviation? And just please. Okay, thank you.
okay, I will start from the bottom. I will start from the down part. Now, the cost of energy, like I said, I have explained the energy mix from the beginning. Like the energy mix ranges from pipe natural gas. If you want me to go more further, I will explain from the LPG, the liquefied petroleum gas, to diesel. Diesel in the energy mix is the most expensive, but the cost varies by countries. The cost varies by country, depends on how they are able to gain access to these various gases. That's how the cost of the energy is. So the cheapest among these gas for power generation is pipe natural gas. It's cheap, and it's cheap. It's very cheap. So it's something you can just incorporate into your unit because it's affordable. It's far less. But the most expensive in the energy mix is diesel. So it's very expensive. So that's that. Then what the GLF panel is the professional name for it. Operators call it synchronization because they don't know the real term, the real meaning of that panels. GLF means generator load field. Generator load field. Load field. LOAD. sorry, LOAD, load, then field, 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 generator.
Yeah, Moses, your voice again interrupted. Yes, Moses, please. Yeah, your mic is muted. Please unmute, please. Yes,
Can
we
you hear me,
cannot.
please?
Yeah, now is okay. Yes, please.
Okay, please, sorry for
You were
the
you
power.
you were talking last time. You were talking GLF, generator load field.
Yeah, generator load field.
Yes.
Is GLF panel, we have two types of GLF panel. So it's the same, is synchronization is one of the function of a GLF panel. Doesn't mean it's a synchronization panel. It's one of the function of a synchronization. Synchronization is one of the function of a GLF panel. So the real name of it is called the GLF panel. So that's where synchronization takes place. That's where you close your breaker for the various outgoing too. So and we have two types of GLF panel. We have the low voltage GLF panel and we have the medium voltage GLF panel. So the low voltage GLF panel is for generator, is linked to a generator directly. So you don't need to go through a step-up transformer to the panel to increase the voltage before you get to the panel. Once you install your generator from the gen shelter, you commission it, you first carry out your E10. Like I said, I will come to maintenance very soon. Because of all these questions, I will digress. Maybe next time, Abib and I will schedule a meeting for maintenance for power plant. So from there, you will learn the various maintenance for it. But I will just tell you one of the maintenance that you do during commission is called E10. So after you do your E10, you do all your check of your major component and your auxiliaries. So what you do, you route your generator, the 415 volts, to your GLF panel. Now, if the generator that you are buying, because some operators or some companies, they have so much money, so they can afford a generator that comes in a rating of 11,000 volt. So in the sense that you don't need to get a step-up transformer before sending generator the load to the various outgoings to the various customers. So all you need to get is just a step-down transformer to step the thing down to 415 so that your supplier can use, your customers can use. So contrary-wise, what am I trying to say in essence? Synchronization is one of the functions of a GLF panel. So the name of that panel is called generator load field. It's a place where generator load harmonize together. It's a place where generator load sync together and being sent to the various customers to inside that same panels. So I don't know if that has answered your question, Abib.
Yes, Moses. Thank you.
Okay. Thermal efficiency of the gas plant. Yes, you can utilize the thermal efficiency of the gas plant by constantly carrying out your various and your required preventive and corrective maintenance when due, and every check when necessary. Because of time, or because of I don't know when we're going to meet again, I will just give you a brevity or a simplified form of what you need to do to carry out the efficiency, increase the thermal efficiency of your gas power plant. First, you need to do what we call E20. E20 is called routine check. So it's expedient and imperative for every operator, gas engineers, gas operation and maintenance engineers to always carry out routine check, because the solenoid valve that supplies oils from the day tank, because before I move further, let me explain something to you. There's a place where you store lubrication oil. For the person that asked the question of lubrication, the place where you store lubrication oil is called a day tank. The place where you put used oil is called a used oil tank. So a day tank is different from your normal drum that you buy oil from, your 209 liters. A day tank can be above 4,000 liters. So sometimes we load our oil using a pump to the day tank. So the essence why routine check is very imperative to increase your efficiency. The solenoid valve that opens and closes for oil to pass through and enter your generator to a allowable volume that the generator needs, and the solenoid valve, is a control component, we cut off. If it's not working, because solenoid valve can fail due to power, can fail due to age, can fail due to wear and tear. So if you don't check, your generator will run down of oil and will shut down. That's one. To increase the efficiency, ensure you carry out your correct preventive maintenance when due, because if preventive maintenance is done on a diesel or a gas generator based on running hours. So on a gas generator, there are certain code that is being incorporated to run a maintenance in order to increase the efficiency, and this code include E30, E40, and E50. And this code has a name. E30 is called preventive maintenance small scale. E40 is called preventive maintenance medium scales, and E50 is preventive maintenance extended. So this maintenance has their own various operations and activities that you engage in. If you don't engage in those activities, you will reduce the efficiency of your generator. If your generator is expected to run on 1 megawatt, you eventually will run that generator that is designed for 1 megawatt for just 500 kilowatts. And when you run from 500 kilowatts, your generator efficiencies are reduced drastically. And also, when your oil change is due, because oil change varies based on companies, because based on what they can, but the standard hour for oil change is 1,000 running hour. If you change your generator for 1,000 running hour, when it's 1,000 running hour on the dot, ensure you do your oil change. So from there, you'll see all the various components of your generator will be running efficiently and effectively without having any effect, any issues. Ensure you blow your air filter consistently. Don't allow your air filter to clog, especially when you are living in an area that is dusty area that is dusty, that when the air is coming, it's come with so much impurities. It can affect the filter. So it's expedient that you carry out several check and routine maintenance, preventive maintenance on your various plants regularly as due to prevent reducing their efficiency. So that's, I don't know if that have answered your question for the thermal efficiency of the gas plant, please.
Okay, Moses, thank you. I think so. Yes, thank you.
Okay.
Those who ask the question, when Moses answered, please acknowledge, please. Thank you.
So for the open and closed cycle turbine, the open turbine is drawing is just closed and open. The term there is just talking about the way you draw air into the unit. That's just a simple analogy of it. Either you use a closed system or you use an open system. Open system, you are using a centrifugal force. The axial and centrifugal unit inside to suck in air. That's for open. Then for closed, you are using external components. That's where this this supercharger will come into play. You are using external component to force in extra air into the component, into the unit to increase the efficiency of the operation. So the whole essence of open and closed is to increase the efficiencies of the operations. One uses external, one uses the internal component to drag in force internal air. That's why some people incorporate this exhaust turbocharger. Exhaust turbocharger is an internal component that you incorporate inside the unit to force in air, extra air into the unit to increase the efficiency of the operations. So supercharger is an external unit that you incorporate on top of the unit to increase the efficiency. They are all the purpose of all these units to increase the efficiency of the various units, not to increase the performance. And nobody have even asked a question about power factor. But anyway, we'll discuss that later. Take time. Okay, Abda, answer your question, please.
Excuse me?
That answer your questions for the open and closed cycle.
Yes, Adnan. I think so. You have asked the question. Is that clear?
Yes, sir. Thank you.
The what's it called? The fossil fuel. Why not using renewables? Hello, my friend. You know, renewable is still growing, but it is the future, undisputed. But you know, when it comes to load, renewable, they are trying to incorporate renewable in order to withstand load because they are increasing them gradually. They are growing gradually to increase the capacity because imagine when you have a unit that stop and run, an equipment that stop and run. I will tell you an example. I don't know if you've worked with any of them have experienced the use of HVAC units, industrial HVAC, like chillers that have up to like 60 horsepower compressor. Chiller that has up to like 120 horsepower compressor. And you know those compressors, when they are in defrost mode, the compressor stop. Then it start counting defrost 1. When it turns defrost 2, compressor still stop. Then when the unit has completely fully defrost, you will see it peak again. And when it peaks, it needs serious power to be able to peak. Renewable cannot do that. So that's how we need the help of fossil fuel. What is a fossil fuel there? A fossil fuel incorporates coal, oil, and natural gas. So these are all the units that is embedded in fossil fuel. And of course, you know, fossil fuel, why they are fighting against it to erase them away from the energy mix because of the effect of their causing to the ozone layers, because they have high ODPs, ozone depletion potentials, and you know those units that have high ODPs, they are affecting they are causing serious global warming. So that's why they are fighting against it. That is why now we are now having the natural gas is now even more cleaner because they've set up a unit called there's something called NOx evaluation, NOx. You take the NOx reading from your gas that's being released from the exhaust part of your gas generator. Then you go and check it. Then you can reduce the value. Thereby, you are controlling the volume of exhaust gases going out of your gas power plants to prevent high depletion or high ODP of the ozone layers. So I don't know if that answers your questions. So there's no way we need more power to be able to run a unit. That's why renewable cannot be utilized alone. cannot use renewable alone because renewable it can only be available not in very big capacity. Because when renewable cannot withstand impact load too, impact load in the sense that we have experience with renewable when I was working with that dairy company. When a load comes like this, a load of like 800 kilowatt come once to your plant, the renewable will shut down. You will have to go and reset the unit back for it to pick up. And that I don't know in your countries how you rate your production, because in some countries, if you lost production for like 1 minute, you have lost millions. So as an operator, you have to be very careful. And as a plant manager, if you are recommending power for your company, you have to also be careful because we bounce back at you whenever they have losses in their productions. So that is why we cannot use renewable alone. We need to use other fossil fuels to support the running of the plant, to prevent downtime, to prevent losses, and it also affects the ROI, return on investment, of the investors that are putting their money to set up their companies. So it's not wise to use only renewable to run a plant. Until renewable is stable, there's enough, because technology is growing. Technology is growing. Like there was a time I was coding, I was into Rust. I learned Rust, Python, Java, and Kotlin. So, and machine learning also. So we are trying to adopt more technology into the renewable system so that we can have more cleaner energy in the society to reduce global warming and ozone depletion potentials. Have I answered the question of fossil fuel and why not using renewables?
Yes, Faizan, I think so. You asked the question. I think so. You got it. The answer. Yes, Moses, please. Next, please.
Okay. So, should I continue?
Yeah, it's up to you. I think so. Session was very long. So, if we want to end, is okay.
I think we should schedule for another meeting.
Yeah, that would be better. I think so.
Yes, because this thing is very, very broad. Because I want them to understand. I don't know. They are students, but they are all students.
Mostly students and some also from other departments and from industry.
Okay.
Mostly students, so yeah. Mostly from electrical and some from mechanical as well.
Okay, because I want us to schedule another lecture because there's a major part that we need to discuss, which is the maintenance aspect and the control aspect. The control aspect is very, very broad, which is the automatic operations. We need to discuss that because in our most industries today, we run on manual operations, and it's really, really scary. That's why I see no most company will not declare the casualty they are having in manual operations because they don't want people to raise an eyebrow on them. Just sweep it under the carpet. In the oil and gas sector, in the energy sector, there's media blackout. Why do I say so? When we have someone that press a breaker or energize a breaker, for example, and the person gets a serious burn on his hand, media will not pick it up. Media blackout. So you will not know the effect of that thing, because if you are seeing a lot of things on the media regarding the effect of manual operation, at least you will be more informed enough to understand that this thing is disastrous, because electricity is not a friend of, it's a respecter of nobody. If a voltage of like 11,000 volts passes through a human body, it's suicidal. It's serious. It's suicide. So that's why it's imperative we incorporate the automatic control system in our various substations to enable the operators and the engineers to have ease operations and run the plant smoothly. And again, it even make them have more knowledge about the power plant, because whenever there's an oil drop or oil leakage or oil shortage or one of the spark plug in the gas generator is having fault, or the ignition coil is not working, stuff like that. You will have a clue from the HMI. You will see everything from the HMI. You will quickly pick up and rush and solve the problem before before the thing leads to downtime. So these are the issues. So it's imperative that we incorporate an automatic control system. And in an automatic control system, we have a lot of sensors incorporated in generators in order to have access to the functionality of the various of that particular component. So like the oil inside the oil have the oil sensor. Then the oil have a sensor. Then all the sensors, they are routed to an ignition system. I've already started discussing control already like this. So just pay attention to this. I'm discussing control like this. So what we call ignition system. Mostly the MWM, the Genpacker, MWM, they have these components embedded in their units, except maybe the manufacturer will take it off and allow the customers or the company that is buying the generators to go and sort for that themselves. Or by standard, a fully controlled embedded generator is supposed to have an ignition system that houses all the feedback from the sensors that have been installed on the various generators. So it's quite imperative that they have that control. Now, inside the gen shelter, there's a panel that I've not mentioned from the beginning of this lecture. The panel is called a AS panel. Please, I believe I would suggest this meeting should be adjourned to. We should postpone it to another day. We should schedule another day for the meeting, maybe next week. Because I have something. They just sent a message now for something I need to attend to.
Yes, Moses, I think so. Yes, you are right. And okay, let's postpone this. And I think so. The next meeting will be on power plant maintenance and control. It would be better, I think so.
Yes, power plant maintenance and control. Perfect.
Yes.
Perfect.
Yes, and some audience also have question. If Sahar and Adnan, if you have question, please ask. Then we will end this session, please. Adnan, Ashraf, and Sahar Akash. I think so. They are not. Yeah.
Question has been answered.
Again, please.
Yes,
please
sir. My question has been answered, so I agree.
Okay. Adnan, do you have any question? Okay, let's end this session. Moses, thank you very much for your long time and detailed answering the question of all the audience, patiently answering all the questions, and your precious time you have spare for us. And I am hopeful that in next session, inshallah, soon we'll meet again, inshallah, on power plant maintenance and control. And I will communicate with you later on for the time, for your availability. And again, thank you very much for your time. Thank you.
You're welcome anytime.
Thank you. Bye-bye. Bye-bye.